Hi everyone and welcome to my YouTube channel. My name is Muhammad Al-Hafi and I'm a Math Olympiad coach. So in this playlist, we'll be discussing one of the most important topics of Math Olympiad, and that is geometry. If you're not familiar with Math Olympiad topics, then check out the video that should appear somewhere here on the screen. So actually in this channel so far we've discussed algebra, which is the first topic of Math Olympiad, and specifically we discussed one subtopic of algebra, and that is functional equation. Now we'll be discussing the second topic of Math Olympiad, and that is geometry. So basically, let's talk about geometry in specific. So as you know, geometry is all about figures. So we have some triangles, some quadrilaterals, and like some circles and so on. And we need to find, for example, to determine some angles, some lengths, to prove that a quadrilateral is cyclic, and so on. So in order to be able to deal with any geometry problem, specifically the hard ones, we need to be familiar with the basic structure of the problem. So basically, all the problems are constructed from simple stuff. For example, we have altitudes, we have angle bisectors, we have centers of the triangle, and so on. So that's why in the beginning of this course we'll be dealing with angle chasing, which means simply that we will be chasing some angles in order to determine their values. Of course, we don't necessarily need to find this angle is 30 degrees, 60 degrees, 90 degrees, and so on. But we just need to find some relations between, for example, the angles, the basic angles of the triangle, like A, B, and C, and to link them with these, for example, with the points we'll be discussing. So basically, now we'll be starting with angle chasing, and specifically with the centers of the triangle. So actually in this video we'll be discussing the first center of the triangle, and that is, as you can see, circumcenter. So if you're just as excited as me, then let's get started. So what is the circumcircle of a triangle? So the circumcircle is simply the center of the circle that passes through the three vertices of a triangle ABC. So basically, let's start by drawing a diagram. So first of all, we'll start by drawing a circle. Okay, I hope it goes fine. Something like that. Okay, and then I'll draw a triangle clearly. Alright, so let's call this triangle ABC. A, B, C. So first of all, like this circle that passes through the three vertices of the triangle, we call this circle the circumcircle. So this circle is simply called the circumcircle. And of course, what is the center of the circumcircle? Well, it is the circumcenter. So that's basically our first center of the triangle, that is the circumcenter. So let's simply draw that. Let's say it's here. Let's call it O. So basically, usually we call these centers of the circles O. So for example, O1, O2 if we have many circles. But usually, when we're referring to the circumcenter, we call it O, usually. Okay, so that's the first thing. Okay, so O is simply the center of this circumcircle that passes through A, B, and C. Okay, so what about this? So actually, in lots of problems, we have the circumcenter, it appears in the problem. That's why we should be familiar with the circumcenter and the circumcircle as well. So one of the basic things that we should know about this is all of its angles. So clearly, when we have O, then we have lots of angles, for example, BOC, OCB, OBC, and so on. That's why in this video we'll be simply just discovering what are these angles. Can we evaluate them? And if we can, then we should actually memorize them, because they are really important, and we don't want to waste time on just these simple things when we have a much more complicated problem. So okay, let's first of all start by simply drawing like the lines, the segments BO and OC and so on. Okay, so let's actually draw that in black. So let's now draw BO. Okay, and then OC. And AO as well. All right. Okay, so the first thing we can say about these like three segments, BO, OC, and OA, is clearly they are equal, right? So BO is equal to OC is equal to OA. All the lengths are equal because O is the center of the circle, right? That means that OB equals OC equals OA, and is of course like it is the radius of the circle itself. Okay, so simply that is equal to this, which is equal to this. All right. So what does that mean? Clearly, since we're like chasing these angles like BOC, OCB, and OBC, since we have like these equal sides, like BO equals OC, then that means that this is an isosceles triangle. And guess what? We really like isosceles triangle because it gives us some relations like regarding angle chasing, right? Because guess what? We know that this angle is the same as this angle, this one is the same as this one, and this one is the same as this one. All right. So now, first of all, let's aim like for this angle. We need to find this angle. Of course, we will find it in terms of the angles of the triangle ABC. So actually, this angle like is A, this angle is B, and this angle is C, with capital letters, of course. Okay, so let's find this angle. So how can we find this angle? Well, actually, let's first of all simply, because this triangle is isosceles, let's put that this angle is the same as this angle. So let's actually call it X. So actually, this is really important when you are solving a Math Olympiad geometry problem. You need like to start naming some variables for the angles. So for example, here, let's start by like defining this as X and this one as X. Of course, this will make your life easy in order like to find relations and like between some angles. Okay, so let's call this X and then this is X, and this one let's call it Y. That means this is Y as well. All right. Since we need to find this one, then it makes sense to find this one and this one, right? And we can do that because guess what? This is X, this is X. So what does that mean? Like this is pi minus 2x, right? Of course, like we can say 180 degrees minus 2x. That depends on whether you're like dealing with radian or with degrees. Okay, so for this one, let's say it's pi. Okay, so pi minus 2x. Because the sum of the angles of a triangle is pi, right? Okay, what about this one? Well, pi minus 2y. All right, what about this one? Now this is easy. So because we know like the sum of these three angles is simply 2 pi, right? That means that this angle is 2x plus 2y. All right, so now we know what is BOC. BOC is 2x plus 2y. But guess what? This is a problem, right? Because we need to find we need to find the angle BOC in terms of A, B, and C, not in terms of x and y. Because remember, we made like up x and y, not the problem setter, right? Okay, so we need to find a way like to represent 2x plus 2y in terms of A, B, and C. But actually this is really simple because guess what? What is 2x plus 2y? Well, let's write it here. Well, simply 2x plus 2y. Okay, let's change the color. Okay, so now we know that BOC is simply equal to 2x plus 2y. Of course, we can take 2 as a common factor here. So 2 times x plus y. And guess what? What is x plus y? Well, take a look here. X plus y is a, right? That means we're done. That means that this is 2 times a. And that means, ladies and gentlemen, that BOC is simply 2a. So now we can erase everything and write this as 2a, right? So let's actually just erase this one here. And write this as 2a. Alright, so now we know what is BOC. Well, what about these two angles? Remember, we need to find OCB and OBC. What about them? Well, that's really easy because since this is an isosceles triangle, then this angle and this angle are equal, right? And in fact, we can easily see that this is pi over 2 minus a, and this is pi over 2 minus a. So actually, this is pi over 2 minus a. And this is the same one, pi over 2 minus a. So actually, by determining all the angles of the triangle BOC, actually we can do the same for the triangle BOA and COA. So simply, what is this angle? It's 2 times B. What is this angle? It's 2 times C. And of course, once we put this one, these three angles, then we can find this one, this one, this one, and this one, easily. So now actually, the first thing you should memorize is the angles of this circumcenter. So always when you have a circumcenter, then you should be able to find this angle. What is this angle? It's 2 times this angle. Okay? Perfect. Okay, but actually we're not done yet, because guess what? Here, what is this angle? It's pi over 2 minus a. However, the angle must be positive, right? But pi over 2 minus a, well, what about if a was greater than pi over 2? Meaning that what about obtuse triangle, right? So what about if a was, for example, 120 degrees? Well, that's a problem, right? So actually, let's discuss that. Now actually we will discuss the case when a is larger than 90 degrees, or that is pi over 2. Okay, so let's draw another diagram for that. All right. Well, actually, we just need to eliminate this triangle. No need to erase the circle. And by the way, a rule of thumb, always start with drawing the circle. When you have a circle in your problem, don't draw first of all the triangle ABC and then draw the circle. This will make your life harder, because then in order to find a circle that passes through the 3 vertices, you can do it. However, it's much harder than doing the opposite, because if you did the opposite, then it's really easy to just choose 3 points, right, on the circle. Okay, so always try to do that. Try to be smart when drawing your diagram. Of course, drawing a good diagram is an essential thing, and we will discuss that actually when we solve much harder problems. Okay, so now actually let's draw an obtuse triangle. So that's easy. Let's say B and C are here. And let's keep A here. All right, now O is still here. Okay, let's erase B and C here. Okay, so now B is here and C is here. Okay, and of course we'll do the same thing now. We'll just connect OB and OC. And guess what? Now we need to find this angle BOC, this one. Okay, clearly now this is not 2A, clearly. So let's find what is the value of this one. Well, actually, luckily, we can still apply the same technique here. So we know that this one is the same as this one, right? Okay, and of course, we can do the same thing. Connect this one here, OA, and we still have this one. It's the same. Now we just need to find the angles here. So let's say this is X. Okay, if this is X, then this as a whole is X. And what is this one? Then this one is just simply pi minus 2x. The same here, y, and pi minus 2y. And what does that mean? That means that the angle BOC is simply 2 pi minus 2x minus 2y, right? Okay, so now actually we need to do a different calculation here. Okay, so what is BOC in this case? Okay, BOC is simply 2 pi minus 2x 2 times x plus y. Of course, x plus y is still a, so we can simply say that this angle is 2 pi minus 2a. And that means like this is the new angle in this case. So now actually you need to put two cases in your mind. The first one, if you've got an acute triangle, then this is simple. You just have like the angle BOC is 2 times a. However, if you have an obtuse triangle, then it's not 2 times a, it's 2 pi minus 2 times a. So just you need to change this thing, and then of course you can find all the angles easily. Alright, so as a conclusion, in this video we've learned to do the angle tracing for all the angles that involve the circumcenter O. Whether the triangle is acute or obtuse, we can always find all the angles regarding O, which is the circumcenter. Okay, so that finished the first center of the triangle, and in the next video we'll be discussing other centers of the triangle. Of course, we'll be dealing with the incenter and orthocenter. So in the next video we'll be dealing with the incenter, and then the other video will be dealing with the orthocenter. Okay, so if you enjoyed the video, please like the video, share and subscribe to the channel, and see you guys in the next video.